Hello everyone, welcome to Wrath of Math Lessons. I'm your host, Sean Ian. In today's video, we are going over how to solve a system of equations using the substitution method. So if you're given two equations, you've got this system that has two equations, you can use the substitution method to figure out where the two lines that those equations represent, where those two lines intersect, which is the solution to the system of equations. And it's basically a 5-step process. It's pretty formulaic, and I think it's pretty intuitive, so hopefully you will be able to do it once this video is over. The 5 steps in general, depending on the example, is to solve for one variable and then to substitute what you solved back into the other equation, solve again, this time getting an actual number, substitute that number back into one of your other equations, and then solve for the other variable. So to sort of make that more clear, of course, let's look at an easy example. So let's say our system of equations is as follows. Y equals 2x, and x plus y equals 24. Now the first step is to solve for one variable, which means we want to know what one variable is equal to in terms of the other variable, or if we know what one variable is equal to just as far as a number goes, that's even better, but that's not usually what we'll have. So here we already have an equation that is solved for one variable, which we know because the only thing on this side of the equation is y, so we know that y is equal to 2x. Alternatively, we could divide both sides by 2 and solve for x, but this is given to us, so we'll just use y because that will be easiest. So we've solved for one variable, we have y equals 2x, then we substitute 2x into y in the other equation. We know y equals 2x, so we can just replace this y with 2x so that we're only dealing with one variable here. So let's go ahead and do that. X plus 2x, substituting 2x in for y, equals 24. And now we are going to solve for x. That's step 3. So we know 3x, adding like terms, equals 24, and therefore dividing both sides by 3, x equals 8. And now we're on to step 4, which is substitute again. Now we have a number value for x, so we can substitute this back into either of our original equations, but it's easiest to substitute it into the one where you already have one variable solved for. We know what x equals, so we'll plug it in here and get y equals 2, substitute 8 in for x, so that's 2 times 8, so y is equal to 16. And therefore, we know that the solution to the system of equations is x equals 8, y equals 16. So the two lines intersect at the point 8, 16. And that's how you do it. We solved for one variable, it was given to us, then we substituted that expression into the other equation, then we were able to use that to solve for our other variable, then we substituted that back into one of our original equations and solved again. So now let's look at a slightly more challenging example, and hopefully that will do it. So now we've got some messier equations with some decimals. We've already got y solved for in this first equation. If 4x was on this side of the equation, of course, we could pick either one to solve for y, and in this case, we could just subtract 4x over to the other side, or excuse me, rather add it, because it would have to be a negative to land over here as a positive. But in any event, it's given to us this way, but it would be pretty easy to solve for either way. But we have y equals 4x minus 17.5. So we've already done the first step. We have an expression solved for one variable. Sorry, I wrote something incorrectly earlier, so just redoing this. So y equals 4x minus 17.5. We can take this and substitute it into this value of y. So we can write 4x, substituting right now, minus 17.5 plus 2x equals 6.5. This is substituting this expression for y into this equation. So now we can add like terms, 4x plus 2x, so we are left with 6x minus 17.5 equals 6.5. And then we just have to add 17.5 to both sides to give us 6x is equal to 24. and then dividing both sides by 6 gives us x equals 4. So now we're on to the last couple steps. We've got x equals 4. Now we substitute it back into our original equation and then solve for y. So I'll just section this off. Now substituting this back into this equation, we have y equals 4 multiplied by 4, because x equals 4, minus 17.5. So y is equal to 16 minus 17.5, so y is equal to negative 1.5. So the solution to this system of equations is x equals 4, y equals negative 1.5. If you were to graph them as lines, they would intersect at the point 4, negative 1.5. And that is how you solve a system of equations using substitution. Thank you very much for watching. Let me know down in the comments if you have any questions or need anything clarified, or have any other video requests if you'd like to see more examples of solving systems of equations using the substitution method. Thank you very much for watching. I'll see you next time, and be sure to subscribe for the swankiest math videos on the internet.
I can hear your voice from all the way up here, dear. Won't you please come to me? You live it up here, dear. There's a light where I float that erases all black. It makes every